Something in the depths of space is drawing perfect spirals. The Hubble Space Telescope has found patterns etched into the cosmos that look exactly like the intricate crop circles found in farm fields, a discovery that blurs the line between natural wonder and something profoundly other. By the end of this, you will understand the full, breathtaking scope of this mystery and the two incredible possibilities that could explain it. We will explore whether this is the universe's most beautiful natural phenomenon or the first faint signature of intelligence beyond our world. What does it say about us that we are so captivated by a pattern in the void? Perched high above our planet, the Hubble Space Telescope sees a universe invisible to our eyes. It is not merely a camera, it is a time machine capturing light that has traveled for millions of years. For over 3 decades, this silent sentinel has orbited Earth, its gaze fixed on the deepest corners of space, and its discoveries have fundamentally rewritten our astronomy textbooks. It has shown us newborn stars blazing to life within pillars of gas, and ancient galaxies colliding in silent, cosmic dances. But its most perplexing finds are often the most subtle. Hubble's suite of instruments, from its powerful cameras to its sensitive spectrographs, acts like a master artist's toolkit. They do not just take pictures, they dissect light, revealing the composition, temperature, and motion of objects billions of light years away. Its resolution is so incredibly sharp that it could spot a pair of fireflies in Tokyo from a rooftop in New York City. This is the precision required to see the faint, delicate spiral patterns etched into the fabric of space itself. Without this technological marvel, these cosmic graffiti would remain invisible, lost in the vast, blurry background of the universe. Hubble's unique position, far above the distorting effects of our atmosphere, gives it a crystal-clear view that no ground-based telescope can ever match. It is this perfect combination of location, power, and longevity that allowed it to notice something that should not be there, a pattern so precise it feels deliberate. The discovery was not of a blindingly bright quasar or a cataclysmic supernova, but of a quiet, intricate design, a whisper in the static that demanded an explanation. The data arrived as a raw, unassuming stream of numbers and pixels. It was just another observation run, one of thousands in Hubble's long career, aimed at a distant star-forming region. But as the image resolved on the screens, one astronomer paused. There, nestled amidst the familiar chaos of cosmic dust and newborn stars, was a shape that made no sense. A perfect spiral. It was not the grand, sweeping spiral of a galaxy, but something far smaller and impossibly intricate, a delicate whirlpool etched into the glowing gas itself. The initial assumption was a ghost in the machine, a digital artifact or a flaw in the image processing. Yet when they recalibrated the instruments and looked again, the spiral remained. It was not an error. The data from Hubble's spectrographs confirmed it was a real structure, composed of the same elemental gases as its surroundings, but arranged with a geometric precision that defied every known law of fluid dynamics and gravitational collapse. A quiet, electrifying disbelief spread through the team. This was not the explosive discovery of a new planet or a black hole. It was something far more subtle and profound. It felt like finding a perfectly carved statue on a barren, untouched mountain peak. The excitement was not one of simple triumph, but of profound confusion. They had found a cosmic fingerprint, and the immediate, pressing question was not what it was, but who or what had left it there. The spirals are not merely shapes, they are structures of almost impossible perfection. Each one spans a truly staggering distance, measuring billions of miles across, a whirlpool so vast it could easily swallow our entire solar system whole. Yet despite this unimaginable scale, the geometry is flawless. The arms of the spiral trace a perfect logarithmic curve, a pattern where each successive coil grows wider at a constant mathematical rate. This is not a chaotic splash of cosmic material, it is a design. You find this same elegant curve in a nautilus shell, in the unfolding frond of a fern, and in the very structure of a hurricane. But here it is etched on a canvas of interstellar gas and dust, far from the familiar confines of a galaxy's disk. This is what makes them so utterly distinct from anything we have catalogued before. A spiral galaxy, for all its beauty, is a messy, gravitational beast. Its arms a jumble of stars, gas, and dark matter, often distorted and incomplete. A planetary nebula can sometimes exhibit symmetrical shapes, but they are the chaotic, expanding death shrouds of sun-like stars, never achieving this kind of razor-sharp mathematical purity. These newly discovered spirals exist in the deep, quiet spaces between the stars, isolated and pristine. They are not the aftermath of a stellar explosion, nor are they the birthplace of new suns. They are something else entirely, a pattern repeated in the void with the precision of a master engineer, and their existence challenges our most fundamental assumptions about how the universe organizes itself. The sheer geometric perfection of these cosmic spirals evokes a mystery much closer to home. For decades, farmers in the English countryside would wake to find their fields transformed overnight. Vast, intricate patterns were pressed into the wheat and barley, complex designs of circles, rings, and pictograms that seemed to appear from nowhere. These were the crop circles, and they sparked a global phenomenon. The earliest were simple circles, but over the years they evolved into breathtakingly complex formations, featuring fractal patterns, intricate star shapes, and spirals that mirror the very ones Hubble has now found in the depths of space. The precision was often astonishing, with stalks bent but not broken, woven into the soil with a technique that baffled agricultural experts. This immediately ignited a fierce and enduring debate. Was this the work of incredibly dedicated and highly artistic human pranksters working under the cover of darkness with nothing more than planks and rope? Or were these formations something else entirely, perhaps the landing marks or messages of visitors from another world? The human explanation was proven when teams of people came forward demonstrating how they could create these elaborate designs. Yet, a persistent fringe of the phenomenon defied easy explanation. With reports of strange lights in the fields the night a circle appeared, and anomalies in the soil and plants that suggested exposure to intense, brief bursts of energy. The parallel is now staggering. We have a pattern of unknown origin etched into the terrestrial landscape, and an almost identical pattern of unknown origin etched into the interstellar landscape. The debate has simply been lifted from the rolling hills of England and projected onto the cosmic scale, forcing us to ask the same haunting question all over again. Are we looking at art, or are we looking at a signature? So the question becomes a simple one. Is this spiral a message, or is it a mirage? Science's first and most crucial task is to rule out the natural before ever considering the supernatural. The leading theory paints a picture of immense, chaotic forces giving birth to an illusion of order. Imagine a star not unlike our own sun, but in a binary system, locked in a gravitational dance with a dense, dying stellar corpse known as a white dwarf. As they orbit one another, the white dwarf's immense gravity acts like a cosmic vacuum, siphoning gas away from its living companion. This stolen material doesn't fall directly onto the white dwarf. Instead, it forms a swirling, superheated disk of plasma around it, a whirlpool of matter called an accretion disk. This disk is a place of unimaginable violence and energy, where friction heats the gas to millions of degrees. According to this model, instabilities within this churning maelstrom could, under very specific conditions, generate a ripple, a spiral density wave that propagates outward. It would be a temporary structure, a frozen snapshot of a shock wave moving through the disk, much like the spiral arm of a hurricane is a wave moving through the atmosphere, not a physical arm of clouds. This would create the precise logarithmic spiral we observe, a cosmic signature written not by intelligence, but by the relentless and beautiful laws of physics. Another possibility involves the strange warping of space itself. Gravitational lensing occurs when the gravity of a massive object, like a galaxy cluster, bends the light from a more distant object behind it, acting as a cosmic magnifying glass. Could a complex alignment of unseen masses be distorting the light from a more ordinary nebula, twisting its appearance into this perfect spiral shape? It would be a grand illusion, a trick of perspective on an interstellar scale. The universe is under no obligation to look the way it truly is from our single, distant vantage point. These explanations are elegant and grounded in known physics, yet they feel almost too convenient. They ask us to accept that nature, in its random chaos, can produce a design of such razor-sharp mathematical purity, not once but apparently multiple times. Is this the simple, sober truth, or are we comforting ourselves with familiar answers in the face of something profoundly unfamiliar? Yet another possibility exists, one that is both deeply natural and profoundly beautiful. These spirals could be the birthplaces of worlds. Around a newborn star, a vast, swirling disk of gas and dust often forms, a celestial nursery known as a protoplanetary disk. Within this churning cloud, microscopic particles of dust collide and stick together, slowly growing into pebbles, then rocks, and eventually the building blocks of planets. Over millions of years, this process can give rise to an entire solar system, with planets carving their orbits through the primordial haze. In many ways, a protoplanetary disk is the universe's most fundamental creative engine. We have observed countless examples of these disks with telescopes, and they frequently appear as smooth, hazy halos around their infant stars. But the spirals spotted by Hubble are different. Their structure is not a vague, glowing smear. The arms are sharply defined, etched into the disk with the clarity of a laser-cut groove. This is the core of the mystery within this hypothesis. Why is the pattern so impossibly crisp? In a typical protoplanetary disk, the material is constantly mixing and churning. Turbulence and heat should blur any delicate structure, like stirring cream into a cup of coffee. For a spiral to remain this distinct, something must be sculpting it, something that imposes order upon the chaos. The most likely culprit is a planet itself. A young, massive planet, still embedded within its natal disk, can exert a tremendous gravitational pull. As it orbits its star, it can sweep through the gas and dust like a cosmic plow, clearing a path and creating dense, compressed waves along its orbit. These spiral density waves are the gravitational fingerprints of an unseen world, a planet so new it is still wrapped in the swirling fabric of its own creation. This explanation is compelling because it connects the spiral to a known, ongoing cosmic process. We are potentially witnessing the very mechanism of planet formation, captured in unprecedented detail. But the perfection of the spiral still gives astronomers pause. The mathematical precision of the logarithmic curve is so exact, it suggests a system of incredible stability and fine-tuning. Is one planet enough to create such a flawless design, or does it require a specific and perhaps rare arrangement of multiple worlds, all pulling on the disk in a delicate gravitational harmony? The spiral may be a natural structure, but its sharpness hints at a level of cosmic order we are only just beginning to appreciate. This very act of observation forces us to confront a staggering truth. We are not just looking across space, we are gazing back through an unimaginable expanse of time. The light captured by Hubble's mirror, the light that paints this perfect spiral on its sensors, is ancient. It began its journey billions of years ago, long before our sun even ignited, while Earth was still a molten rock. By the time this faint photon completes its cosmic voyage and enters our telescope, the spiral that created it may have long since dissipated, its constituent gases scattered back into the interstellar void. We are not seeing it as it is, but only as it was, a fossilized echo of a moment frozen in the deep past. This is the fundamental challenge of cosmic archaeology. The universe presents us with a single, static image, but that image is a lie of perspective. It is a composite of events that happened at different times across distances so vast they defy human comprehension. To say these spirals are billions of miles across is almost meaningless. A billion miles is a number, but the reality is a structure so large that light itself, the fastest thing in existence, would take hours just to travel from one end of the spiral to the other. Our entire solar system, from the Sun to the distant orbit of Neptune, would be a mere speck against this colossal design. This scale mocks our intuition. We are trying to decipher the intent or the natural cause behind a monument we can only see in a single, faded photograph, a monument that may have already crumbled to dust by the time we first laid eyes on it. The spiral is both there and not there, a permanent question mark written in transient light. Gravity itself could be the cosmic artist behind these spirals, sculpting light into perfect shapes through a phenomenon known as gravitational lensing. This is not magic, but a direct consequence of Einstein's theory of relativity, where mass warps the very fabric of space and time. Imagine space as a vast, taut rubber sheet. Place a heavy bowling ball in the center and it creates a deep dip. Now roll a marble past the bowling ball. The marble's path will curve, not because a force pulls it, but because it is following the curved surface. Light behaves in exactly the same way. Even though it has no mass, a beam of light will bend and curve as it travels through the dips and valleys in space-time created by massive objects like galaxy clusters or black holes. This turns the universe into a funhouse of natural lenses. We have seen this in action many times before. The Hubble telescope has captured stunning images of Einstein rings, where the light from a distant galaxy is bent by an intervening mass into a perfect luminous circle. In other cases, the same background galaxy can appear multiple times in a single image, mirrored and smeared into long, faint arcs around the foreground cluster. It is a well-documented cosmic illusion. So could a specific, complex alignment of masses be warping the light from a perfectly ordinary, perhaps even boring cloud of gas? Could the gravity of an unseen galaxy or a swarm of dark matter be twisting its appearance into that impossibly precise logarithmic spiral? The mathematics suggest it is possible. A spiral pattern could emerge from the intricate interplay of lensing effects, a mirage of geometry painted onto the cosmic canvas. This explanation is profoundly elegant, relying on nothing more than the established laws of physics. Yet it asks us to accept an astronomical coincidence of almost unbelievable perfection. For the lensing to create such a sharp, symmetrical spiral, the alignment of the background object, the lensing mass, and our own line of sight would have to be exquisitely precise. It would be like a pebble falling into a pond and creating not random ripples but a flawlessly etched spiral wave. Is the universe truly that full of such perfect accidents? Or does this elegant natural explanation simply push the mystery of design one step further back? But what if the spiral is neither an illusion nor a nursery? What if its geometric perfection is exactly what it appears to be, a deliberate construction? This leads us to the most speculative and thrilling possibility of all, that we are not looking at a natural phenomenon, but at a technosignature. A technosignature is any sign or signal that provides evidence of advanced technology, a marker of intelligence etched across the cosmos. We have spent decades listening for radio signals, searching for a hello in the static. But what if the message is not a sound but a shape? A spiral of such scale and precision could be a megastructure, an artifact of engineering on a level we can barely comprehend. Imagine a civilization so advanced that it builds not with steel and concrete, but with gravity and starlight. Perhaps this spiral is a Dyson swarm, a vast collection of energy collecting satellites orbiting a star in a perfect, mathematically optimal pattern to capture every last photon of its power. Or maybe it is something else entirely, a cosmic clock, a navigational beacon for interstellar travel, or a work of art meant to be seen from 1,000 light years away. The sheer permanence of the form is what gives this idea its haunting weight. A radio signal is fleeting, a momentary shout that fades into the background noise. But a structure, or the shadow of one, could endure for millennia, a permanent monument in the galactic archive. It would be a message designed not for a single generation, but for cosmic eternity, a way for a civilization to declare we were here. This idea forces us to confront our own place in the universe. Are we the only ones who look up at the stars and wonder, or are we merely the newest listeners in a conversation that has been going on for billions of years? The spiral hangs in the void, silent and enigmatic, and it offers no easy answers. This spiral in the void feels strangely familiar, as if we have seen its blueprint before in the pages of our own science fiction. For generations, storytellers have dreamed of what an advanced alien civilization might build. Freeman Dyson, a visionary physicist, proposed a theoretical megastructure that now bears his name. A Dyson sphere would be a colossal shell built around a star to capture its entire energy output. While a solid shell is likely impossible, a Dyson swarm, a vast constellation of energy collecting satellites in a precise orbital dance, is theoretically feasible. The spiral Hubble observed could be the shadow of such an unimaginable project, a pattern of countless orbiting platforms so vast it tints the star's light with a geometric signature. Or perhaps it is something even more profound, like the communication array from the film Contact, a machine of cosmic scale designed not for energy but for connection. Science fiction has long been a playground for these ideas, a space to explore the aesthetic and practical implications of intelligence operating on a galactic stage. For decades, these concepts were purely speculative, thought experiments confined to conferences and novels. Now, with the discovery of this real, observable spiral, the line between imaginative fiction and rigorous scientific inquiry has not just blurred, it has nearly vanished. The same scientists who once debated these ideas as philosophical exercises are now forced to consider them as potential explanations for actual data. This is the moment where our stories collide with the universe. We have been writing the script for First Contact for a century, and now the cosmos may have handed us the first page of a dialogue we never truly believed would begin. The spiral hangs there, a cosmic Rorschach test, and we cannot help but project our grandest dreams and deepest fears onto its perfect curves. Astronomers are now training the world's most powerful telescopes on these spirals in a relentless vigil. This is not a passive observation, it is an active hunt for a second act. The core question is simple yet profound: does the spiral change? A natural phenomenon, no matter how beautiful, will follow the predictable, if violent, laws of physics. An accretion disk spiral density wave will slowly dissipate. A protoplanetary disk will eventually be cleared by its newborn planets. But what if the spiral does something else? What if it pulses with a regular rhythm, or if a new, identical spiral appears near a different star, a cosmic signature repeated across the galaxy? The search for these changes is conducted with the same meticulous patience as the search for extraterrestrial radio signals. In the classic SETI program, scientists scan the heavens, listening for a narrow-band radio transmission, a signal that stands out from the natural background static of the universe because its very structure implies a technological origin. A repeating pattern of prime numbers, for instance, cannot be produced by a quasar or a pulsar. It is a hallmark of a mind. The hunt for a changing spiral operates on the same fundamental principle. Scientists are analyzing the light from these structures with a level of scrutiny usually reserved for distant exoplanet atmospheres. They are breaking the spiral's glow down into its constituent colors, searching for subtle, repeating variations in its brightness or temperature. A flicker that repeats every 10 hours or a specific sequence of dimming and brightening could be the key. It could indicate a structure with moving parts, a vast orbital dance of constituent pieces, or perhaps even an intentional modulation, a signal embedded not in radio waves but in the very architecture of the object itself. The universe is a noisy place filled with variable stars that pulse and flare on their own natural schedules. The monumental challenge is to distinguish a random cosmic heartbeat from one that has the distinct, unnatural rhythm of a message. The silent spiral hangs in the data, and we are listening with our eyes, waiting for it to speak. This spiral is not the first cosmic messenger to arrive without a return address. The history of astronomy is punctuated by these profound enigmas, phenomena that appear, dazzle us with their mystery, and then refuse to fit neatly into any of our scientific boxes. Each one is a puzzle box from the depths of space, challenging our assumptions and forcing us to rewrite the rules. Consider the case of Oumuamua, the first known interstellar object to pass through our solar system. In 2017, telescopes detected a strange, tumbling rock hurtling past the Sun at a speed that confirmed it was not from here. It was not its origin that caused such a stir, but its bizarre characteristics. It was oddly elongated, shaped like a flattened cigar, and as it sped away, it exhibited a slight but undeniable acceleration that could not be explained by gravity alone. Outgassing, the typical explanation for such a push, would have left a visible coma of gas and dust a tail. Oumuamua had none. It was a dark, silent, and strangely propelled visitor. Then there are the fast radio bursts. These are not objects but events, incredibly powerful flashes of radio waves that last for mere milliseconds. They erupt from random points in the sky, delivering in a fraction of a second the same energy our Sun emits over 3 days. Some of these bursts are one-off explosions, cosmic cries in the dark. Others repeat, firing off signals from the same patch of sky with no discernible pattern. We have detected them from sources billions of light years away, and their cause remains one of the most heated debates in astrophysics. Are they the result of colliding neutron stars, the explosive deaths of magnetars, or something else entirely? These anomalies, from the strange acceleration of Oumuamua to the inexplicable power of fast radio bursts, form a pattern. They are not failures of our science, but its greatest successes. They are the universe pointing a finger at the gaps in our knowledge, reminding us that our current understanding is a mere island in a vast ocean of the unknown. The spiral fits perfectly into this grand tradition. It is another question mark written in the sky, another cosmic riddle waiting for its key. When the first images of the spiral reached the public, the reaction was instantaneous and electric. Headlines screamed about alien messages and cosmic crop circles, tapping directly into a deep cultural fascination with the unknown. Social media platforms lit up with speculation, each post and share adding another layer of myth to the raw data. The spiral became more than an astronomical object. It transformed into a canvas for our collective imagination. People saw ancient symbols, divine messages, and proof of civilizations far older than our own. This public hunger for a monumental answer created a powerful feedback loop, where the most sensational interpretation was often the one that gained the most traction, overshadowing the careful, methodical work of the scientists actually studying the phenomenon. The chasm between the two narratives became starkly evident. On one side were the sober press releases from research institutions, filled with cautious phrases like anomalous structure and potential natural explanations. These documents outline the competing hypotheses, from accretion disks to gravitational lensing, without ever committing to a single, thrilling answer. They were maps of a complicated territory drawn to scale. On the other side were the viral articles and video clips, their thumbnails dominated by glowing, otherworldly spirals and bold, declarative text asking if we had finally found them. This was not a map, it was a treasure hunt. The difference is not merely one of style, but of fundamental purpose. The scientific process is inherently slow, built on peer review, skepticism, and the gradual accumulation of evidence. It is a discipline of doubt, Public discourse, especially in the age of digital media, thrives on certainty and revelation. It seeks the story, the answer, the closure that science is often unable to provide. We are left with a fascinating duality. The same spiral exists as two separate entities, the data point in an astrophysics journal and the symbol of first contact in the public mind. This tells us less about the nature of the spiral itself, and far more about our own desperate, beautiful need to not be alone in the immense and silent cosmos. The scientific community greets this cosmic spiral with a deeply ingrained and necessary skepticism. For every breathtaking claim of a new discovery, there exists a fundamental rule, a guiding principle that has protected the integrity of science for centuries. Extraordinary claims require extraordinary evidence. This phrase, made famous by astronomer Carl Sagan, is not a dismissal of wonder but a shield against error. The claim that a structure in space might be artificial is perhaps the most extraordinary claim it is possible to make. Therefore, the evidence required to support it must be ironclad, unambiguous, and overwhelming. A beautiful shape, no matter how geometrically perfect, is not enough. It is a starting point for investigation, not a conclusion. The entire history of astronomy is filled with seemingly mysterious phenomena that later yielded to a natural explanation. The canals of Mars were once thought by many to be the work of a dying civilization, until better telescopes revealed them to be an optical illusion. Pulsars, when first discovered, were jokingly nicknamed LGM for little green men because their perfectly timed radio pulses seemed so artificial, until they were understood to be the rapidly spinning corpses of massive stars. The spiral enters this long tradition of cosmic mysteries, and the burden is on those who see a signature of intelligence to prove that no natural cause can possibly account for it. This is not a refusal to believe, but a rigorous demand for proof. The process of peer review acts as the gatekeeper for these ideas. Before any revolutionary theory about the spiral's origin can be taken seriously, it must be submitted to the merciless scrutiny of other experts in the field. These anonymous reviewers will pick apart the methodology, challenge the assumptions, and demand that every other conceivable explanation be ruled out. They will ask the hard questions. Could the data be misinterpreted? Are there flaws in the image processing? Have all known models of accretion disks or gravitational lensing been thoroughly tested and found wanting? This process is slow, often frustrating, and inherently conservative by design. Its purpose is not to stifle innovation, but to prevent the entire edifice of science from being built on a foundation of sand. A single beautiful anomaly is a curiosity, a pattern of evidence verified independently and surviving repeated attempts to disprove it is a revolution. Right now, the spiral remains a magnificent curiosity, a question written in light, awaiting the extraordinary evidence that will force the world to reconsider everything it thinks it knows. There is one more theory, so wild it exists at the very fringe of physics. Imagine a vessel, a ship not built for oceans or atmospheres, but for the void between stars. To cross the unimaginable gulfs of interstellar space, such a craft would need a propulsion system beyond our comprehension, one that doesn't push against anything, but instead manipulates the very fabric of space-time. This is the realm of theoretical physics, where concepts like the Alcubierre warp drive are seriously debated. The idea is to create a warp bubble, contracting space-time in front of the ship and expanding it behind, effectively allowing the vessel to ride a wave of distorted space. It would not move through space, but would carry a pocket of space itself, sidestepping the universal speed limit of light. Now, consider what such a journey might leave in its wake. The violent, controlled manipulation of space-time would not be a clean process. The transition, the sudden warping, and subsequent snapping back to normal could create a ripple, a shock wave in the very structure of reality. And what is the most stable, efficient shape for energy to dissipate in a fluid medium, whether it's water, air, or the quantum foam of space-time itself? A spiral. This theory suggests we are not looking at a structure at all, but at a contrail, the temporary scar of a passage. The perfect logarithmic curve would be the fossilized imprint of a warp bubble's oscillation, a signature of a technology so advanced it writes its signature on the cosmos not with light or radio waves, but with geometry etched directly into the dimensions we inhabit. It is a breathtaking proposition. The spiral is not a message and it is not a mirage. It is a footprint, the ghost of a journey taken eons ago by a traveler we can scarcely imagine, a single frame from a voyage of which we have seen only the fading spray. At the heart of this cosmic mystery lies a number, a mathematical constant so profound it seems woven into the fabric of reality itself. The spiral observed by Hubble follows a precise logarithmic curve, a pattern governed by the golden ratio. This ratio, approximately 1.618 to 1, appears with an uncanny frequency in the natural world. You can see it in the arrangement of seeds in a sunflower's face, in the spiral of a nautilus shell, and in the proportions of your own hand. It is a pattern that is both incredibly efficient and aesthetically pleasing, a fundamental rhythm of growth and form. This specific mathematical signature raises a monumental question. Is its presence in the distant gas clouds merely a coincidence, one more example of this universal constant asserting itself, or is it a deliberate design choice? The Fibonacci sequence is a series of numbers where each number is the sum of the two preceding ones, starting from 0 and 1. This sequence 0, 1, 1, 2, 3, 5, 8, and so on, has a direct and beautiful relationship with the golden ratio. As the sequence progresses, the ratio between successive numbers gets closer and closer to the golden ratio. This mathematical dance creates the very same logarithmic spiral we are seeing in space. When nature builds something, it often follows the path of least resistance, and the Fibonacci spiral represents the most efficient way to pack growing structures, like the leaves on a stem or the florets on a broccoli, maximizing exposure to sun and rain. So, a distant accretion disk or a protoplanetary disk could naturally settle into this most efficient, stable configuration. It is the universe doing what it does best, finding the simplest and most elegant solution to a problem of physics and growth. Yet, the sheer crispness of the spiral observed by Hubble gives even this elegant natural explanation a moment of pause. Natural Fibonacci spirals here on Earth have a certain organic softness to them. The spiral in space is razor-sharp, its arms etched with a geometric clarity that feels more like a blueprint than an emergent property. This is the core of the debate between universal constant and intelligent design. One side argues that the universe is simply expressing its inherent mathematical nature on a grand scale. The other wonders if a mind, recognizing the elegance and universality of this ratio, chose it as a signature precisely because it is a language the universe itself understands. Is the spiral a happy accident of physics, or is it a message written in the one dialect that any advanced intelligence anywhere would be guaranteed to recognize? The spiral's silence may not last much longer. We are on the verge of a new era of observation, armed with a tool that can see things Hubble never could. The James Webb Space Telescope, orbiting 1 million miles from Earth, is not just an upgrade, it is a revolution. Where Hubble primarily sees invisible light, the kind our eyes can perceive, Webb sees in the infrared, the realm of heat. This is the critical difference. An object in space that is cold or shrouded in thick dust is nearly invisible to Hubble, but it glows brightly to Webb's infrared eyes. For the mystery of the spiral, this changes everything. Webb can peer directly into the heart of the structure, analyzing the temperature and composition of its gases with a precision Hubble could only dream of. Is the spiral warm, like the violent maelstrom of an accretion disk, or is it relatively cool, like the quiet nursery of a protoplanetary disk? The answer lies in the heat signature, a truth Webb is uniquely equipped to reveal. Furthermore, its immense mirror and sensitive instruments can dissect the light from the spiral in incredible detail, searching for the chemical fingerprints of complex molecules. Finding certain organic compounds or an unexpected mix of elements could tilt the scales heavily toward one explanation over another. It is the difference between looking at a silhouette and being able to read the fine print. Webb can also monitor the spiral for changes over time, watching for the subtle shifts and pulses that would betray its true nature. A natural phenomenon will evolve according to the slow, predictable clock of physics. Something else might behave differently. With Webb now actively observing the cosmos, we are no longer just staring at a single, enigmatic photograph. We are waiting for the subject of that photograph to finally move, to give us a clue we can truly understand. Proof of an alien intelligence would shatter a cornerstone of modern science, the Copernican principle. For centuries, this idea has been our guiding star, insisting that we occupy no special place in the cosmos. The Earth is not the center of the solar system. The Sun is an average star in a mundane galaxy, and there is nothing privileged about our position in the universe. This principle has been a humbling and powerful tool for discovery, constantly pushing our perspective outward. But if we were to confirm that one of these spirals is a constructed artifact, the Copernican principle would face its greatest challenge. We would have to confront the staggering possibility that we are, in fact, special, not for our location but for our timing. We would be the newcomers, the young species who has just stumbled upon the ruins or the active workshop of a civilization so ancient its works are written in star stuff. Our entire timeline of history, from the pyramids to the internet, would shrink into a single, fleeting moment at the very end of a cosmic story that has been unfolding for billions of years. The universe would suddenly feel crowded, not with aliens in ships, but with ghosts of intellects whose thoughts are expressed on a scale we can barely measure, let alone comprehend. This revelation would force a profound shift in our identity, moving us from being the lone observers of a vast, empty stage to being the audience who has just arrived for the final act of a play that began long before our planet even formed. The silence of space would no longer feel empty, but pregnant with the echoes of conversations we are only now learning to hear. That history of earthly hoaxes casts a long shadow over this cosmic discovery. Here on our own planet, the crop circle phenomenon began with simple, crude circles, creations of local pranksters. But as public fascination grew, so did the artistry and the deception. Teams of people armed with nothing more than planks, rope, and a keen sense of geometry proved they could create breathtakingly complex designs under the cover of darkness. They demonstrated their techniques openly, showing how they could flatten crops in intricate patterns that, from the air, looked impossibly perfect. For every genuine mystery that remained, there were a dozen elaborate fakes. This legacy teaches a crucial lesson about the human mind and our desire for wonder. We are pattern-seeking creatures, and we are storytellers. We so deeply want the universe to be filled with magic and meaning that we are sometimes willing to supply the magic ourselves, even if it is a fabrication. This is the cautionary tale that every astronomer carries with them when they look at the Hubble spiral. The human capacity for creating elaborate, beautiful deceptions is well documented and profound. Could we be doing the same thing on a cosmic scale, not with planks and rope, but with our own biases and interpretations? The scientific method was forged in the fire of this very human tendency. It is a system designed to protect us from our own enthusiasm, to separate the signal from the noise we ourselves create. The hard-won skepticism from the crop circle era is not a cynical dismissal of the extraordinary. It is a disciplined filter, a set of rules to ensure that when we finally do announce a discovery of this magnitude, it is built on a foundation of evidence so solid that no human hands, no matter how clever, could have possibly faked it. The spiral in space may be billions of miles away, but the greatest hurdle to understanding it might just be the one we carry inside our own heads. This global mystery has triggered an equally global response. Astronomers from observatories on every continent are now pooling their resources in a coordinated effort to understand the spiral. It is no longer a single team's puzzle, but a shared human endeavor. Each major telescope acts as a different sense, gathering a unique piece of the puzzle. Radio telescopes, like the vast ALMA array in the high deserts of Chile, are listening for the faint whispers of cold gas and dust within the spiral's arms, mapping its raw material. The Chandra X-ray Observatory, orbiting high above Earth, pierces the veil with its high-energy vision, searching for the telltale signature of superheated plasma that would scream of a violent accretion disk. Meanwhile, infrared observatories, both in space and on remote mountaintops, are measuring the gentle warmth of the structure, trying to determine if it is a stellar nursery or something far colder. This multi-wavelength approach is like diagnosing a patient by taking their temperature, a blood test, and an X-ray all at once. No single observation can reveal the whole truth. By stitching together these different views, from the long, lazy waves of radio to the short, piercing spikes of X-rays, scientists are building a composite portrait of the phenomenon. They are not just looking at a picture anymore, they are assembling a three-dimensional model of its physics, its chemistry, and its life story. This kind of international collaboration is the bedrock of modern astronomy, turning isolated points of light into a story we can all begin to read. While professional telescopes scan the skies, another force is at work analyzing the spiral, a global army of curious minds. The data from Hubble and other observatories is vast, a sprawling digital universe of images and measurements that no single research team could ever hope to sift through completely. This is where the power of the crowd becomes indispensable. Online citizen science platforms have thrown the doors open to everyone, inviting amateur astronomers and curious individuals from all walks of life to join the investigation. A retired teacher in Lisbon, a college student in Tokyo, and a farmer in Kansas can all log on and examine the same raw data that sits on a professional astrophysicist's desk. They are not just passive observers, they are active classifiers, their collective attention forming a net so fine that almost nothing slips through. How does this actually work in practice? Imagine you are presented with a gallery of countless images of the spiral, each taken at a slightly different wavelength or a different moment in time. Your task is simple: to look for anything that seems out of the ordinary. Does one section of the spiral appear brighter than the rest? Is there a tiny, anomalous speck of light nestled within one of its arms? The human brain is exquisitely skilled at pattern recognition, often outperforming even the most sophisticated computer algorithms at spotting subtle anomalies. One person might notice a faint, flickering star in the background that a computer would dismiss as noise. Another might flag a barely perceptible kink in the spiral's arm. These individual observations, these tiny flags planted in the data, are then aggregated. When dozens or even hundreds of independent users all mark the same peculiar feature, it rises to the top of the list for professional astronomers to investigate with their powerful instruments. This is the true power of citizen science. It turns a mountain of data into a curated map of mysteries, highlighting the most promising paths for further exploration. The spiral is no longer just a subject for a handful of experts in ivory towers. It has become a shared puzzle for all of humanity to solve, a testament to the idea that the next great discovery might not come from a PhD, but from the sharp eyes and relentless curiosity of someone just like you. Perhaps the most mind-bending explanations for the spiral lie entirely outside our current understanding of physics. The universe might not be playing by the rules we have so carefully written in our textbooks. We must venture into the realm of theoretical physics, where ideas like cosmic strings are debated. A cosmic string is not a piece of thread, but a hypothetical crack in the universe, a one-dimensional flaw in the fabric of space-time that formed during the intense, searing moments after the Big Bang. Think of it as a scar left over from the birth of the cosmos itself. These strings would be unimaginably dense and under immense tension, thinner than an atom yet possessing the mass of an entire mountain range crammed into every inch. As such an object moves through the interstellar medium, its colossal gravity would pull and shear the surrounding gas, potentially creating a wake of disturbed material. If a cosmic string were to vibrate or oscillate in a specific way, could it whip through a cloud of gas and sculpt it into that perfect logarithmic spiral we observe? It would be a natural process, but one born from the most exotic and fundamental defects in reality. Similarly, physicists have long hunted for a magnetic monopole, a hypothetical particle that is a solitary north or south magnetic pole, unlike every magnet we have ever seen which always has both. The existence of such particles is predicted by grand unified theories, models that attempt to stitch together all the fundamental forces of nature. A monopole of sufficient power would be a cosmic anomaly, its intense magnetic field potentially capable of channeling and organizing vast clouds of charged plasma into coherent, spiraling structures. These are not ideas of alien engineers, but predictions from our most ambitious attempts to describe how the universe works at its deepest level. The spiral, then, could be the first experimental evidence for physics that operates on a scale we have never before been able to test. It would be a message not from another civilization, but from the universe itself, revealing a layer of its own operating system that has remained hidden from us until now. This spiral speaks to something ancient within us, a deep-seated need to find meaning in the patterns of the world. We are, by our very nature, storytellers and pattern seekers. For our distant ancestors, connecting the dots in the night sky was a matter of survival, a way to navigate the world and mark the changing seasons. They saw heroes, gods, and great beasts written in the constellations, transforming the cold, impersonal stars into a cosmic epic. This spiral is the modern incarnation of that same instinct. It is a pattern we recognize, a shape that feels intentional, and so we cannot help but project a story onto it. The question of whether we are alone in the universe is perhaps the most profound we can ask. It touches upon our deepest fears of isolation and our grandest hopes for connection. To consider that we might be the only conscious beings in this vast, silent cosmos is a terrifyingly lonely thought. But the alternative, that we are just one voice in a great cosmic choir, is equally humbling and awe-inspiring. This single, enigmatic spiral perfectly bridges that chasm between the known and the unknown. It is a real, observable object grounded in data and science, yet it points toward possibilities that stretch the very limits of our imagination. We are captivated because it offers no easy answers, only a beautiful, haunting question. It allows us to stand on the edge of the great unknown, peering into the darkness, and wonder if something is peering back. That moment of shared curiosity, of collective wonder, is a powerful reminder that we are all, in the end, looking up at the same sky, united by the same timeless mystery. So we stand before this cosmic question mark, faced with two equally compelling narratives. On one hand, the spiral is a masterpiece of natural physics, a temporary density wave in a churning accretion disk, or the gravitational fingerprint of a newborn planet in its stellar nursery. These explanations are elegant, grounded in the known laws of the universe, and require no leap of faith beyond the incredible beauty of physics itself. On the other hand, the spiral's razor-sharp perfection and mathematical purity whisper of something more, a technosignature left by an intelligence that builds on a scale we can scarcely comprehend. This is the realm of megastructures, cosmic beacons, and the profound hope that we are not the universe's only storytellers. The evidence, as it stands, refuses to tip the scales decisively. Every observation that seems to support one theory finds a plausible counterpoint in the other. The spiral remains a perfect enigma, a silent sphinx in the void that guards its secret closely. This is not a failure of science, but its very essence. The universe has presented us with a riddle, and the pursuit of the answer is what propels us forward. The true value of this discovery may not be in a final resolution, but in the journey of inquiry it has ignited across the globe. The mystery of the spiral is an open invitation to remain curious, to keep looking up, and to question everything. As the James Webb Telescope and a new generation of observatories continue their vigil, we may yet find the clue that unravels it all. Until then, the question hangs in the space between the stars, a shared puzzle for all of humanity. What do you believe this spiral represents? Share your own theories in the comments below, and let's continue this cosmic conversation together.